Let's wait for 2 to 3 minutes, okay? Let other
Yes,
students
you.
also. You are from IIT Delhi?
Yes.
I did my masters from IIT Delhi only.
You are also from IIT Delhi.
Yes.
Oh, sorry.
I did my masters from IIT Delhi.
Now you are in which IIT?
IIT Bombay.
Okay, sure, man.
You are master's student there or
Yes,
BSMS?
ma'am. No, no. I am master's student here.
Is my screen visible?
Yes, ma'am. It's visible.
Okay, let's start the class. Good evening, everyone. I'm Rakhi Yadav, your PMRF teaching assistant from IIT Bombay for Pericyclic and Organic Photochemistry course, which is conducted by NPTEL and whose course instructor is Professor S. Sankararaman from IIT Madras. So, students, in this week too, we are going to cover problems based on various cycloaddition reactions. So, can anyone tell me what are cycloaddition reaction by looking at this term?
Other are also. Okay.
They are
Yeah.
coming or
No.
not? Let's. Okay, no issue. Just let's start the class.
Okay, ma'am. We can start.
Uh, can you please mute yourself?
Yes, you, ma'am.
Huh.
Sorry.
So, in first 5 to 10 minutes, we are going to cover theory of cycloaddition reaction, and then we will start solving problems. So, cycloaddition reaction is that pericyclic reaction in which there will be two components. They are going to add in cyclic fashion, and what you will observe, let's say we have this famous Diels alder reaction. On cyclization, it will form this cyclohexene. So if we look at the starting materials, they are having total 3 pi bonds, right? And in product we are having 1 pi bond, and two new sigma bond has been formed, right? So basically, in Diels-Alder reaction, you are making new sigma bonds at cost of 2 pi bonds, right? So, in conclusion, there can be two types of cycloaddition reaction, or it depends on component to component. There can be 6 plus 4, 2 plus 2, 4 plus 2. Okay. In 2 plus 2, there can be cycloaddition between two olefins, or one olefin, one ketene, and another third one is your famous Paterno-Bucci type reaction in which one cycloaddition partner is your ketone and another is your olefin. And in 4 plus 2, which is famous Diels-Alder reaction, one is your diene part and another is your dienophile. And in 4 plus 2, other two possibilities are 1,3 dipolar cycloaddition, which we are going to cover in next week, and another is kilotropic reactions. So these are the some key points of Diels alder reaction. So since in last week I have told you how to draw all these FMO, frontier molecular based orbitals. So let's say we are having this diene, right, and this olefin, okay, or we can say that dinophile. Why we are saying it dinophile? Let's look at its molecular orbital picture. If you remember from last class, since there are four carbon atoms, so there will be four wave function associated with it. And in total, how many pi electrons are there in this diene? Four, right? So we will fill it like this. I am just drawing end orbitals, okay? Hmm. And for your ethylene type system, this is your psi 1 and this is your psi 2. Now, Arjun, tell me in ground state, or we can say that in thermal condition, which is going to be your HOMO of this diene among these four wave function?
Um, Ground state will be Psi2, Psi2 will be HOMO, and Psi3 will be LUMO.
See, we have to take a HOMO of one component and LUMO of another component. Okay. So,
Hmm.
first possibility is that you are taking HOMO of your diene and LUMO of your olefin.
Hmm.
Got it?
It's the general case,
Huh.
no? We take diene as means HOMO
We
part
can take other way
and
or we can
dienophile. Yeah,
we
retro. It's reverse. Yeah, retro. I don't exactly remember the name. What we can
we
call
will
it.
look at other way around also, but let's first say we are taking HOMO of diene and LUMO of your dinophile. Okay. In ground state, psi 2 is your HOMO, right? Of diene.
Yes, ma'am.
This is your psi 2. Okay. And
Hmm.
LUMO, this is your ethylene. So LUMO is this. HOMO is highest occupied molecular orbital and LUMO is lowest unoccupied molecular orbital, right?
Hmm.
So this is your HOMO, this is your LUMO. Till
Hmm.
here it is clear now?
Yes, ma'am.
Okay. Now, in this cycloaddition type reaction, new terminology come suprafacial and terrafacial. Okay, when these two lobes are interacting from same face, okay, then that is suprafacial, and if they have to do constructive overlap from opposite face, that is interfacial. Now let's understand here only. Just give me 1 minute. Just you remember the molecular orbital signs of end orbitals as they are going to react. Other orbitals are going to remain same. So this is your diene part and this is your HOMO, right? Positive, negative, negative, positive. And this is your diene and its LUMO is, let's say its LUMO, draw this way. Is it okay, Arjun, to draw this way, right?
Yes, ma'am.
So we are having,
Yes, ma'am. Yes.
so this can easily make this bonding interaction in ground state. Clear?
Hmm.
But
Hmm.
let's say there is photochemical condition. Then in that condition, your psi 3 will be HOMO. And in psi
Hmm.
3 case, these orbitals will be of same sign. Then it will not be
Hmm.
possible to have suprafacial. Here,
Mm-hmm.
there 4 pi is your suprafacial component and 2 pi is also your suprafacial component.
Suprafacial component.
Therefore, it is thermally allowed reaction and photochemically forbidden. Is this concept clear to you?
Yeah, sure, ma'am. That's
Okay,
fine.
good, good. So this was I was telling that suprafacial is making bonds from same side. See this way, and in this case you can do constructive overlap of these two lobes. But
But there is
for
antibonding.
their collision, you have to do from other way around, right?
Hmm.
So this was your FMO approach. From here, we can know that we should know that for 4 plus 2 type of reaction, thermal conditions are required. Okay, let's move ahead.
Hmm.
We will go through this theory part quickly, and then we will come to problem. So this was your molecular orbital interactions for Diels-Alder reaction. You have to take HOMO of your diene and LUMO of your dienophile, right? One more possibility you were saying there. Let me draw that one also. What say if you take HOMO of your two partner and LUMO of your four part? You also draw and tell me. I am also drawing and tell me what is the problem in this condition. If we are taking LUMO, so in ground state its LUMO will be psi 3. I am drawing directly, okay? Just I am drawing end orbitals. So this is going to be your LUMO of diene partner, correct? And of your olefin, this is going to be your HOMO, correct? These can also take part. Then why we are not taking this way around? Can you tell me if you have gone through sir's lecture?
Um, this concept I don't know, ma'am, actually.
Okay, let me tell you. See, both are possible. We can take HOMO of one, but you have to take HOMO of one, LUMO of other, not HOMO and LUMO of same molecule. Okay. Now comes
Yes, ma'am.
another phenomena, that is diene and dienophile. Dienophile means it is quite electron deficient, right? So your basically in a
Dying should be electron deficient.
no, I am saying your diene should be electron rich,
Hmm.
right? But your dienophile, this is your dienophile, which is electron deficient. I was saying this.
Hmm.
Hmm. If you have any doubt, you can just tell me, okay? So I was saying
Yes, ma'am.
for any organic chemistry mechanisms, if we go on mechanistic aspects, we know that difference between this homo lumo should be as low as possible, correct?
Yes, yes, ma'am.
For efficient electron transfer, correct? So you have to pump in electrons in your diene part so that homo can go above, because uh, as we know, more the molecule is having electron, energy wise it will go above, yes or no?
Yes, ma'am.
And more the electron deficient will be your lumo, this will come down, correct?
Yeah. Energy of
Therefore,
LUMO will decrease.
huh, very good. Therefore, your diene part should be electron rich. Group attached to it should be either plus M or plus I.
Plus I.
Yes. And for your diene part, it should be electron deficient. So group attached to it should be minus M or minus I. Got it? Yes or no?
Yes, ma'am.
Here I have told you why you have to take homo of your diene part and lumo of your dienophile. Okay. Now, now comes regioselectivity in Diels-Alder reaction. Let me. Regioselectivity means, see, there are two possibilities. Let's say your, let's say you have, this is your diene, okay? Now this
Yes.
dienophile, let's say it is having this electron withdrawing group. Now it will prefer, generally Diels-Alder reactions prefer endo attack. Endo attack means substituents attached to this olefin should point towards your diene part. Why? Due to stabilizing secondary orbital interaction.
Transition state got stabilized due to
Very
secondary
good.
orbital
Because
interaction.
this substituent should be endo with respect to this diene. Okay. Students have joined or no? Okay. Prashant, are you getting what I'm telling? Okay. We were discussing regioselectivity in Diels-Alder reaction. So first case is your substituted dienes. Either they will give ortho product or they will give meta product. So students, remember this. See, in pericyclic reaction, we can't talk about charges. But just for understanding purpose, I am telling, if we draw resonating structure of this, right? Final negative charge will come on this carbon, yes or no? It will become like this. Sorry, let me erase this. It will be like double bond OMe positive. This bond will come here and this here. Till here it is clear, right? So if we draw
Yes.
resonating structure, your negative charge will be here and your positive charge will be here. I'm just telling positive charge will be here. It is not carbocation, okay? And if we look at here, this is your electron withdrawing group. So in both the, let's say it is position A, let's say this is position B. So where negative charge will be stable? At A or B?
At
Prashant
B.
and B. Okay. At B it will be stable, so positive charge will come here. See, I am telling you all this just for understanding purpose. You can solve any question by this concept, but in real this concept comes from orbital coefficient. Okay. This thing you
Mhm.
can read from what the book name is, Ian Fleming. There they talked
I'm fine.
about orbital coefficients, but for our understanding purposes to solve questions, you can draw this way, that where this positive and negative charge should be there. So now you just have to connect these two and this positive with this negative. Correct? That's why in regio selective purpose, your OMe and your this group, electron withdrawing group, are 1 2 with respect to each other. Clear? Therefore, whenever you are drawing this Diels-Alder product, you are getting 1 2 product as your major product. Clear?
Yes, ma'am.
Okay. How you can draw this? Here negative charge will become, right? So you can draw arrow like this. Actually, I am using pen na, so got it? Okay. Now in second case, just draw this resonating structure as I have drawn and tell me, is this correct? That para is major and meta is minor. Other students, if you got how I have came to conclusion in case number 1, then tell me, when there is 2 substituted diene, means diene is substituted at position number 2, is this product will be measured? Why? Because if you draw resonating structure, obviously lone pair will go from here and negative charge will come here, correct? So this part is going to attack here, because in this case negative charge will come here and positive here. Yes or no?
Yes, ma'am.
If you draw these imaginary charges, na, you will get to know what regioisomer you have to draw in your exam. So, by looking at this slide, you can make conclusion for your competitive exam is that in Diels alder reaction, product is not observed in normal cases, right? Either you will get 1,2 product or you will get 1,4 product. Yes or no? I hope regio
Yes, ma'am.
selectivity of Diels alder reaction is clear. See, I am discussing this theory for next 5 minutes. Then I am going to solve questions and I am going to ask from each of you. Okay. If it is clear, last factor that is remaining is stereochemistry of Diels-Alder reaction. So one best thing about is pericyclic reactions are that they are stereospecific. So can anyone tell me what are stereospecific reactions? In normal language, just tell me.
It is like reactants are in cis, product will also be in cis, and reactants are in trans. Stereochemistry will be preserved in product part. Means if
uh,
it is trans, it will be in
your
trans.
first statement can't be always true, right? For example, if you remember that electrocyclic reaction, if they are disrotation, then cis will become trans there, right? So basically, more appropriate definition of stereospecific reaction is that stereochemistry of your product will be determined by stereochemistry of your reactant. Understood?
Yeah, this is yeah.
Okay, good. Now see, with respect to your file, which is this. Remember when I have told you that FMO approach for 4 plus 2 reaction. Sorry for this. So we came to conclusion that it was 4 pi s plus 2 pi s. S is your suprafacial. Yes. If they are suprafacial, if substituents are cis in your file, they will be cis in your product also. And if they are trans in your reactant, they will be trans in your product. Yes or no? So if you have to draw stereo with respect to this, you just one another possibility is also there, that you can draw this way at dash CO2 R can may be there. Okay. So this is also true. But you should know the relative stereochemistry of both the substituents. So first point to note from this slide is stereospecific with your file. Next point is with respect to diene. With respect to diene, if since these A groups are opposite side, right? They are outside facing A groups. One is going above and another one is going down, outside facing. And in these B groups are inside your pi framework. Yes or no? So while giving stereo, you have to give same stereo to A group and same stereo to B group. Yes or no? Till here it is clear. After that, I will tell you how they are coming in this way.
Yes.
Okay. Now, third part is your most complicated, that you are having substituted diene and substituted dienophile. In this case, how you have to do? I am just telling. This is my way to do. You can also do like this. You just draw a line, simplified version, dashed line. Okay. This is line. I'm not able to draw it is exactly. Let's say we are having this molecule. Okay, let's take their molecule only. Just draw diene over there, same as it is given. See, at carbon number 1, CH3 is above, so just draw this CH3 on this line. Okay, and at carbon number 4, it is down, so M. After I complete this part, I will ask. Okay, so if you are not getting, tell me. And these hydrogens are facing downside, or we can say that inside. Sorry. Now, as I have told you, this diene part should be reacted in endo fashion. Endo fashion means this substituent should see this diene for secondary orbital overlap. So just let's extend this line. Draw your diene and obviously make sure that electron withdrawing group should see inside your this line. Why? Because this is endo approach. Now, what you have to do in your final product, whatever groups are on line and left side, line which are on line and left side, give them same stereo. So your Me will, let's say your Me is on wedge. So Me here is on wedge. Now, can anyone tell me where this COOH group will be there, wedge or dash? Quick. I'm again telling, whatever substituents are there on line and left of this line will be having same stereo. Understood? We
Okay,
will
okay,
solve
okay.
some problem, then you will know this.
Yeah, I got it.
Okay. So if you got it, just tell me. Let's say we are having this methyl. Okay. And in your dino file, one group is your, let's say, NO2 and another group is your OMe. I am drawing product also. You just have to tell me stereo, okay? By using this line approach. Let's say I am drawing these methyls on wedge. Because as per rule number 1, they will come on same side. Now tell me, NO2 will be on wedge or dash?
NO2 will be on wedge.
Very good, very good. NO2 will be on wedge. Why? Because, and OMe will be on dash. Why NO2
Hmm.
is on wedge? Because when we keep these two groups trans to each other, among NO2 and OMe, we will keep electron withdrawing group inside. Why? Due to secondary orbital interaction,
Secondary
your
orbital
electron
interaction.
withdrawing group should be inside of your diene. Okay. For understanding purpose, I have drawn this diene below. Otherwise, you can imagine here that your diene is here, right? And this is your endo approach. Electron withdrawing groups are here. Understood? Shall we move on to
Yes.
problems?
Yeah, we can.
Okay, good. So I will ask one by one. Okay. So for question number 1, they are asking diene which can give Diels elder reaction is. So who is going to tell me? Just tell me your name. I will write, and then he will answer. For one question, it is of 2 marks. Okay. If you are having any problem in between, you can stop me and ask. Okay, who is going to give answer to question number 1?
I can give, ma'am, but if
Your
others are
name?
willing, let them give.
No, no, your name first come first serve.
Arjun,
Okay, Arjun. I'm writing A. So, Arjun, tell me answer with proper reason, okay? Tell me which diene can give Diels-Alder reaction.
option number D means the diene which is given in D option, it should react and give Diels-Alder reaction.
Okay. So,
Ops,
Arjun
uh,
is saying option number D is correct. Okay. Why other option are wrong? What is the
option
first
A,
condition for diene? It should be
electron rich, of course, and
okay.
one is
Another
that it should be in cis-wide form.
very
Means
good.
it's
First condition should be it should be cissoid. What cissoid means? These double bond should be cis around this single
in
bond.
cis.
Okay. So see, in this case they are not conjugated at all. So we can cut this option. In this case they are
That
trans
is
to each
true.
other. And in case number A, what is the problem, Arjun?
Ma'am, actually, those two tertiary butyl groups will cause a lot of steric hindrance. It will not
Therefore,
stay in the cis-wide
yeah,
conformation.
therefore it will not stay in this cis
Chetan,
conformation. It will interconvert to its transform, right? Yes or no? Therefore, option number D is most appropriate. Everyone, is it clear? Sunil, Prashant,
हाँ यस मैम बोलिए.
okay, is it clear na?
यस मैम प्लीज.
Okay, okay. Now, can you please tell me answer for question number 2, as we have discussed theory part for all these type of reactions? That they are asking correct order of reactivity of diene in Diels-Alder reaction is. Take your time and give me accurate answer. For this hint is you are taking HOMO of your diene. HOMO means it should be electron rich or deficient.
should be electron rich.
Yes, more it will be electron rich, more will be above your HOMO, and HOMO LUMO gap will be lower, right? Remember, HOMO is here for your diene part and LUMO is here. More electron you pump into this HOMO, it will go above and this energy gap will be low. And less will be the energy gap, more is the reactivity. Now tell me which option is correct.
It should be like option C, most probably.
Who is telling answer? Just tell
Ma'am, Arjun.
me, Arjuni, okay. See, this question has a kick that among all these dienes, this is always going to remain in its SS form. Yes or no?
Cis-wide conformation.
Therefore, it is most
Yeah,
reactive. So, option in which first is not in front, you can delete them. Right? Now, among these three options, one thing is clear that chloro one will go at last because chloro halogens have minus I effect, right? So 4 is at your last. So this can be correct option and this can also be correct. So option number B gets eliminated. Now among A and B, A and C, how you have decided, Arjun, among option number A and C?
Ma'am, it was about plus M and minus, matlab plus M
Very good.
and
See
uh,
here, it is having, let's say it is having hyperconjugation effect also, but leave that. It is having plus I effect, and here it is having plus M effect, and we know that plus M effect is more dominating than plus I. So most appropriate answer is your first, third, second, fourth. Very good. Third, diene which can give Diels-Alder reaction is. And these are basic questions from this topic. You all should answer. These are all have appeared in your competitive exams. Diene, which can give Diels alder reaction. Okay, tell me one by one. Can first diene can give? Yes or no?
Yeah, it is in cis-wide conformation, it will give.
Okay. Second,
No, it is in permanent trans form.
very
It
good.
will not.
Third, it can go in
It can,
cis.
cis, it can.
Okay, so we will write yeah. And it can also go. It will form a
Yeah.
bridge bicyclic system like this. Yes or no?
Hmm. Huh.
So it can. So appropriate answer is one, third, and fourth. So option
Hmm.
number B is most appropriate. Everyone understood till here? Okay. After this class, you should not leave any question in your competitive exams regarding this Diels-Alder reaction. Okay. So tell me, in this reaction, what is your diene and which is your dinophile?
First one is diene, means जो भी है. And the second one is
So,
dinophile.
how are you going to give stereochemistry? Let
Again,
me
that the rule.
see that line rule is not there in books. I have just made it for your uh, understanding purpose. One thing is clear: if you don't know about stereo, how you have to approach these type of questions. You know very well that whatever stereo is there in your reactant, it should be there in your product. Since these
It
groups
should be
are
present.
trans, so these should be trans. You can't, yes, trans is there, but this option gets eliminated because CO2 MER is in this option. So you can eliminate this option. Now, among option A and B, which is correct? Obviously, B is
Option A
correct.
will get eliminated.
Why? Because these two methyl are on line. The things which are on line, they should have same stereo, right? So this is your main product among all these options. Understood? Okay. This is very good question. Take a pose and tell me the correct answer. Okay, let's start doing this question. How you have to approach this question? Okay, tell me among SPH and CH3, which is more electron donating group among SPH and methyl, which is more electron
Sulfur will
donating
donate through its
plus
lone
M,
pair present. So
mesomeric we
plus
can
M.
call it, and this is your plus I.
Hmm.
So obviously, uh, if you draw on line SPH, SPH, and here methyl will come. Okay. Now, among these two olefins in cyclohexadiene, let's say this is part 1, this is part 2. Which will behave here as dinophile? 1 or 2?
2 will behave as dinophile.
Why? Because
More
NO2
electron
group is
deficient.
attached to it. Very good. So, one thing is clear that you are going to get this product SPH, Me, and since this is more electron donating and NO2 is more electron withdrawing, so they are going to be at 1 2 position to each other. Correct?
Hmm.
And another double bond would be intact. And so this is your product. Now you have to tell me stereo. Just put it on line and tell me the stereo. Or you can
SPH.
Okay, tell me.
SPS, methyl, and NO2 all will be on, मतलब relatively cis.
Very good. Why? Because, and another
Ma'am,
way,
again that,
ask.
no, no, I was
Okay, okay.
telling the secondary or vital concept.
Yes, and this hydrogen and NO2 are cis, right? So in
Hmm.
product also they are going to be, but there is no okay. Option number one is there. See here,
Hmm.
NO2 and hydrogen are on same side, so they will be same in product also. Yes or no?
Hmm.
So
Hmm.
option number A is most appropriate. Yes, everyone
Yes, ma'am.
clear? Okay. So this is your problem number 6. First, you can easily see that first is your Diels alder reaction, and after that,
Hydrolysis.
hydrolysis. So take your time and tell me the correct answer. Okay, let's start solving this problem. Okay, so first reaction is your Diels alder reaction, and we very well know that product will be 1 2 or 1 4 or 1 3. Everyone,
It may
substitute.
be 1 2 or 1 4. It will
But
not be 1
since
3.
but since OMe is not on terminal carbon, so it will be 1
Hmm.
4. So one thing
1
is
4.
clear, this is your product, right?
Hmm.
Okay.
Option 1, मतलब A and
Now
C.
they are saying hydrolysis part. So what is the next step after this? Obviously, first tell me.
OMA will get protonated or something like that.
First it will be like this, right? And this negative charge hydrogen H plus will take. Now on hydrolysis it will form your double bond O. So which option is this? Your option number C, I think. Yes.
Hmm.
So option number C is most appropriate here. Everyone, is it clear or not? And Arjun, if you are first protonating this, right? Then which bond you are going to move? That's why
No, it will be
first
direct.
oxygen lone pair will come down. It will get protonated, and after that hydrolysis will lead to formation of this keto. Okay.
Yes, ma'am.
Now tell me, how are you going to approach this problem? Okay, first step is simple. What is this? That is your simple disorder reaction. See,
Hmm.
students, in your exams, in your MSc exams or whatever exams you give, uh, always pericyclic reactions are one of the step of that reaction. Okay, not sole reaction. Here, first your disorder reaction will takes place. Then, in presence of butyl lithium, what will happen? Ylide will form, right?
Hmm.
And then that ylide is going to do Wittig reaction with your aldehyde.
Hmm. Hmm.
So I have given you the sequence of reaction. Now just try to solve this problem. Always Diels-Alder reaction, they will use it in application part. I am also solving this question. Before that, tell me answer. So first step is your in, intermolecular Diels alder reaction. Correct? First step.
Hmm. It's fine.
Why I have drawn here only? Because PPH3 is also having some sort of electron deficient character, right?
Hmm.
Huh. In second step, butyl lithium is there. Butyl lithium is nothing but your strong base. Strong base is going to abstract proton from here, correct?
Yes, ma'am.
And then it is going to give elide. Elide are nothing but, now nothing is left. You just have to do intermolecular Wittig reaction. Now the last question here comes is whether this will be E or Z.
It will be Z because a elite that is formed is non-stabilized.
Very good. Elites can be of two type. Either it can be stabilized or not stabilized. See, stabilized with respect to what? This carbon ion, right? Since this
Hmm.
carbon ion is stabilized by nothing, so this will come under category of unstabilized elide. And we know that for stabilized elide, we got E alkene, and for unstabilized, we got Z alkene. Okay, students. So which is most appropriate answer? See here 1 3 cut. 1 3 cut. Among these 1 4, which option will be more appropriate? That will be your Z. Now another question comes here. Either this will be having more priority or this.
And down one will be having more priority
Why?
because
Because
it
just
is
after
more.
one carbon olefin is coming, and here after two carbon this olefin is coming. Therefore, this is Z. So most appropriate answer is C. Very good. Everyone understood now? Or I will explain again. Only Arjun is giving answer. Other students, Riha, have you understood? Okay. So let's move to next problem. Major product formed in the given reaction is, okay. First step they are saying magnesium is there. Ether is nothing but your solvent. What is the role of magnesium? Magnesium generally insert between your carbon and halogen bond. Yes or no?
Grignard reagent
Huh.
formation type.
Good. Now, in among which bond it will be inserted? Among Mg or F or Mg or Br?
I don't know this concept, ma'am. Under which.
You have you ever read about intermediate benzene?
Yeah, yeah. I know in this case benzene will form, but if you are asking, it will most probably it will be like Br. Mg will be inserted between Br.
Why? Because we can relate it to our daily life example. From where third person
Yeah,
can come, where two bonds are weak, right? So among C and F and C and bromine, this bond can easily cleave, right?
clear.
So in principle, MgBr will come. Now it is not having any option. It just have to do, and this fluorine will knock off, and you will get this benzene, right? Now you are having benzene, and you should know very well that benzynes are very good two partner among your 4 plus 2 cycloaddition reaction. Okay.
Yes, ma'am.
So this is your two pi partner. Now tell me, what is this? Naphthalene, anthracene, or phenanthrene?
It is anthracene, no? It's the
Are you sure?
yeah, it's
Yes,
anthracene.
yes. Because naphthalene are having two rings, anthracene
Two.
is three, and anthracene they are linearly fused, and in phenanthrene one, two, and one is above them, or we can say that
Hmm.
they are not linearly fused in that. Okay. Among these all the pi bonds, according to you, which ring will undergo Diels-Alder reaction without any loss? Which loss I am talking about here? Can anyone tell me?
Without
Lo-
any.
Without any aromaticity loss. Among these
Okay.
three rings, you just have to choose that two part, or we can say that diene, which can give at least two rings aromaticity. You understood what I'm telling?
Oh, I
Among
got it.
these all the pi bonds, you have to choose a pair of that pi bond which can give other two rings aromaticity. Obviously, this diene is going to take part. How? Because when it will undergo Diels-Alder reaction, here double bond will come. So
Hmm.
ring number one and third will become aromatic, right?
Hmm. Hmm.
And this in between ring will undergo Diels-Alder. So option number A is wrong, B is also wrong, C is correct. Correct or not?
Yes,
So
ma'am.
most appropriate answer is C.
Oh, thank you.
Nice
Thank
question,
you.
na? Benzene
Yeah,
followed by
yeah.
Diels-Alder reaction. In last
And
problem, what we
that,
have seen, Diels-Alder followed by Wittig reaction. So in organic, you should remember all the type of reactions, Wittig, and all the reactions based on your intermediate, carbene, benzene, nitrene. Okay, let's move to next problem. Actually, this can be an example of kilotropic reaction, but you can solve.
allotropic.
Huh. Just tell me, hint is 4 plus 2 reaction will take place only. You just have to tell me product.
Yeah, then it's option A. It's simple.
Are you sure
But
it is option number A?
yeah,
Have you read anywhere if there is possibility of removing SO2, CO2, CO, N2,
yeah,
you have
gas
to
will
do,
get emitted, entropy
will
change.
increase. Yes, very good. So, but you were right. Your first product will be this. Um, sorry, sorry for my drawing. SO2, and one double bond will come here. Correct.
Hmm.
Now what will happen? This bond, okay, that is going behind. It will come here. This will go there, and this bond will come here. If you draw it, you will get this. Have I drawn it wrong? Wait, let me redraw it. Now I have given you hint. You can also tell me answer by drawing. I am also drawing. Just wait.
Yeah, I think then it's options. nahi.
क्या SO2. Now tell me which bond will cleave. so that SO2 can be removed.
ये यहाँ गया.
Take your time and tell me among C and D which option is correct.
Option A.
Option number A. Option number A is first step. That is correct. But then I have told you after Diels-Alder reaction, SO2 molecule will leave. Now you have to tell me which is most appropriate product. Okay. Time up. C or D?
Ma'am, not sure.
What?
Ma'am, I'm still not sure because in D aromaticity is getting lost.
But in okay. So you are thinking to see. It is not always necessary that after removal aromaticity will come. Okay.
Yes.
Because one of the driving force for removal of these molecule is aromaticity.
Hmm.
Here it will come or not. Okay, we will come to the same question after all the question has been done. Okay, let's complete them. Then we will come to this problem. This is problem number right. Problem number 9. Okay. Now tell me how you are going to solve this question. This question can be solved by a person who has attended my last week tutorial based on electrocyclic reaction. I have told them that whenever you have seen cyclobutene
First, it will be like
and heat is
electrocyclization
there.
ring opening,
Yes,
and then after
very good.
it will be plus to
So
cycloaddition.
first step is your electrocyclic ring opening. Then you are getting hint na in second step what can happen? Diels-Alder reaction can take place. Third is your simple acidic hydrolysis. Now I have given you hint. You just try to solve. I am also solving along with you. So this type of diene you will get. Okay, having OMe both side. OMe and another is your OM. Yes or not? Till here, no issue. After
No, ma'am.
that, after that, okay. Now it comes about regiochemistry, where this pen has. This is having two OMe groups, which means 2 plus M groups, right? So obviously, whatever that CHO will come, but since this is symmetrical dinophile, so no issue of that. You got till here, and one thing is missing. Tell me, this should be double bond, right? Because it was alkyne.
Yeah.
Now at last they are saying acidic hydrolysis. That will just make this acetal, or we can say that ketal, not acetal. It will change into this keto. Correct?
Yes, ma'am.
So which option is this? Let's see option wise. CHO, okay, but they are
Hmm.
not hydrolyzed since in second step hydrolysis is there. So option number A gets eliminated. In option number B, is everything right? Yes.
Hmm.
Option number C, is it correct?
OH group is there.
See, they are showing
Yeah,
aromaticity,
enol, enol.
but from where this proton is abstracted, you are getting na. So this product is not possible, and option D can't be true. You all got na why C can't be true,
Hmm.
because if we are having system like this, let's say we are having double bond O, sorry, then this tautomerism can happen to gain aromaticity, right? This arrow is not correct, but then tautomerism can take place. But here in this case, these are not conjugated, right?
Hmm.
Therefore, it will stop to this product. I hope I am clear to everyone. So first step was 4 pi electrocyclic ring opening, then followed by Diels-Alder reaction, and third step is your simple hydrolysis. And with this, we are done with Diels-Alder problems. Now we will have just brief recap of 2 plus 2 cycloaddition. Now can anyone tell me which is most symmetrically allowed condition for 2 plus 2 cycloaddition, heat or photochemical?
Photochemical conditions.
Okay, we will understand this by FMO approach. Okay, just wait. I will tell you this on brief, and we will solve one good problem based on this. See, this is your ethylene, right? Homo loom. Let's say this is a heating condition. So obviously in heating condition, this psi 1 will be your homo and psi 2 will be your lumo. Because homo is highest occupied molecular orbital and lumo is your lowest unoccupied molecular. Now to having suprafacial interaction like this. Okay, you can do constructive overlap of this law, but what about this? You have to collide interfacial then this law to have constructive overlap. Therefore, 2 plus 2 cycloaddition reaction of two olefins, remember two olefins is not possible under heating condition or thermal condition. Got it? Now second condition is your H mu. Under photochemical condition, this is going to be your homo psi 2. One of the electron will excite into psi 2, and we know that psi 2 have different orbital sign and orbital signs are different. Okay, and LUMO is your same. Here you can have constructive overlap. Therefore, for 2 plus 2 cycloaddition between two olefins, the most appropriate condition is photochemical. Understood?
Yes, ma'am.
Okay. This is your gate PYQ. Take 1 minute and start solving this question. And one of you can tell me how to approach these questions. See, in step number A, base is given. What base can do here?
It will abstract acidic proton and it
Which
will eventually lead to
oh,
formation of ketene tag.
Okay, very good. That means you have solved this question previously, right? Or
I don't have
yes?
encountered this type of questions.
Okay. For others, let me tell you, he was right. Since this is your most acidic proton, since this is between sandwich between two chlorine and one electron withdrawing group, right? So first base is going to abstract this proton. Negative charge will come here. It will come back and will knock off this chlorine. Let me draw for you what happened here. Okay. So after getting ketene, there are two possible reactions. One is 4 plus 2 reaction, one is 2 plus 2 reaction. Now, who is going to tell me which reaction will take place here?
2 plus 2 will take
With reason. See, this is your hydrogen, okay? Base is going to take this proton and you will get Cl, Cl, double bond C. Correct? We got this ketene, right? Now you should know that, and in next class, come with reason why ketene can't undergo 4 plus 2 reactions. Okay, here it will go 2 plus 2 cycloaddition. In next class, I want answer for this question. Let me write it here. Why ketenes can't undergo 4 plus 2 cycloaddition reaction. Okay. So let's say now they are saying, now there are two possibilities. Okay. And in ketene case, it is clear to everyone na, that this is going to be your positive or negative. Obviously, positive center, and this is going to your negative. Positive means electron deficient. One thing I am again telling you, in pericyclic reactions, charges are not there, they are just imaginary. For understanding purpose, we are just drawing. Okay, so you just have to at- connect these bonds. Now tell me, among 1 and 2, which polarity is correct and why? Okay, before that, let me ask you one general organic chemistry based question. If you have to stabilize carbocation and carbanion among these two intermediates, to which you will give priority?
carbocation is given more priority.
Very good, because carbanion is carbanion will get C. If positive charge is here in case number one, it is not in conjugation with this double bond, right? It will just face minus I of this double bond, because after
Hmm.
getting one carbon away this become sp2, and sp2 are more electronegative comparison to sp3. So no advantage to carb cation here, but here it is in conjugation with this double bond. So among
Hmm.
option number 1 and 2, this, where is, sorry. So this is correct. Now you just have to draw, because two regioisomers were possible here. I am telling you how to approach. Now since negative charge is here, so it will bind to this carbon. Okay. So you will get this. Everyone is clear till option number A.
Yes, ma'am.
Now can anyone tell me in zinc acetic acid condition? Uh, yes, zinc acetic acid condition. What will happen?
It's reducing agent, most probably.
Zinc is reducing agent. Okay, then what will happen?
Zinc in acetic acid reduces.
Everyone have written mechanism of this question or not? I have erased actually. Huh. So what were you telling?
Ma'am, after that I am not
Okay, I
able
will tell
to.
you. I will tell you. See, you got this product, right? Double bond Cl. You will learn new thing here. Zinc is what? Zinc is your D10.
Ma- Yeah,
It
D10.
means electron rich. It is electron rich. What will happen?
Yeah.
Zinc will donate electron to this oxygen, and this bond will cleave like this, positive, negative, and then negative charge will knock off one of the chlorine. Okay. So what you will get? Double bond here, chlorine, OZN. Zn will become positive after donating its electron to oxygen. So it will take chlorine, Cl negative, which gets knocked off from here. Till here it is
Hmm.
clear na?
Hmm.
I have made some mistake over here. Yes, this was not okay. Now what will happen? Can anyone tell me? Acidic condition is there. Okay. Double bond O will come here and Cl. See, this is now this has become enolate, right? Oxygen lone pair will come here and this will abstract this proton in acidic condition. So you will get this. Till here, everyone.
Okay, okay, okay. Yes,
Now
ma'am.
again zinc will see this is good problem. This is from one of the suggested book for gate. I have taken from there. So zinc again it will donate its electron density here.
Hmm.
It will become OZnCl and again it will knock off one chlorine. Okay.
Hmm.
And at last after hydrolysis it will become, so in total what zinc acetic acid have condition have done? Dehalogenation. Zinc
Yeah.
acetic acid condition have removed these two chlorine atoms. Okay. Now the last step you will tell me. What is H2O2 role here? Has anyone
It will
studied about beer
give
vinegars?
oxidation. Oh, air vinegar oxidation.
Okay. Now there are two possibility. One is this, and another is this. Which two possibilities there? One is your epoxidation, and another is your one oxygen get
Air
inserted
vinegar.
between. Beer vinegar oxidation. Now tell me. See, for vinegar oxidation, your that olefin should be electron rich. Yes or no?
Air vinegar
But
oxidation.
this olefin is relatively not stable. It is not having that much electron density. Apart from this, it will try to release this four-membered ring angle strain. Yes or no?
Hmm.
It
Yeah.
will try to
Yeah.
become five-member ring. Okay. Now oxygen will get insert between. It can insert here and here. Now tell me, among these two products, which will be your major product? I am drawing. One is your this product and another is your, which is more correct among option number A and B.
Option number A should be the correct one.
See, yes, because this is more substituted carbon among this carbon and this carbon. So obviously oxygen will insert here. Okay. So this is your product B. So basically this is 2 plus 2 cycloaddition reaction between your ketene generated and your cyclopentadiene. First reaction is simple 2 plus 2 cycloaddition, and second is your dehalogenation, and in third step beer vinegar oxidation type of reaction is taken place. Understood?
Ma'am, for epoxidation to take place, alkene should be electron rich.
See, this is not always condition, but here if you compare electron richness of this double bond and angle strain, we have to give more priority to angle strain. Okay.
Yeah, 4 member ring
Otherwise,
is not that much
huh,
stable.
otherwise it is not necessary. Since let's say you are having simple your olefin, ethylene, and you are reacting it with MCPBA, so obviously it will go undergo epoxidation. But
Yeah,
since here angle strain is reducing, therefore we are getting this product. Understood now?
yes, ma'am. It was a very nice question.
Hmm. And this was also a nice question. Which one? These were.
This one.
Okay. As these are mixed problem for from all the organic reactions. Okay, this problem we will discuss in next class. Whether this product will stop to this product or this. Okay. Now just
Okay, ma'am.
tell me, you want me to discuss ketene cycloaddition part? Why ketene cycloaddition takes place in presence of heat, not in presence of photochemical condition, or you will study?
Ma'am, we will first, I think
Okay,
you should let us
okay.
study.
Let me give you hint. Then you can try by yourself. Okay. I will suggest you all to read that Claydon. New
Okay.
slide is not coming actually. Okay. Let's remove this. Thank you. Huh. I'm giving you a hint for that ketene part. Okay. You have to think in this. Let's say this is your simple ketene. Okay. CH2.
Hmm.
What is the hybridization of this middle carbon? sp, right? And this is your sp2
SP?
carbon. Yes.
Hmm.
Now, for this pi bond, obviously, this bonding interaction has taken place. Correct? For this pi bond. And for oxygen case, there are three p orbitals, right? Px, py, pz. If
Hmm.
one is this, another possibility is this also, right? So let's say with
Yes.
oxygen it has formed this bond.
Okay.
So this is orbital picture of your ketene, right? Another hint is you have to take LUMO of your ketene. This is your orbital picture of ketene. You have to use this, and you have to take HOMO of one. In one case, you have to take HOMO of your this diene, and another case you have to take HOMO of your simple olefin. Then you will get to know that in case of this simple olefin, you will have more bonding character. Okay, that's why 4 plus 2 reaction between ketene and diene is not possible, but 2 plus 2 reaction between ketene and olefin is possible. You got na? You just have to keep
Yes, ma'am.
homo orbital picture in between this picture and then you will get to know which interactions are favorable. Okay, so thank you students for joining this class. I hope you all have understood.
Thank you, ma'am. Have learned
Okay,
so many new concepts today.
okay, thank you. Now you all
Okay,
can
ma'am.
leave the class, and I will upload all these slides and
Madam,
video. What?
madam, there is one query
Yeah, you can ask.
that I have not got the assignment number first because I registered later. That
uh,
about 26,
Sorry
27.
Prashant, I couldn't listen. What? Could you please speak again?
Ma'am, I have not got the assignment first because
Okay.
I registered later in this course. That is about
See,
23
this assignment
January.
problem, you have to talk to that Harini ma'am, I think. All these authorities, we don't have.
Ma'am, which to
Uh,
whom I have to come? Ma'am, to
uh,
whom I have to talk?
See, in that YouTube link which you will get now of these slides and all, I will upload that. I will upload there that email of that. I think that is Harini ma'am only. She can only handle these problems of assignment and
Okay.
all.
Ma'am,
I
any
don't.
contact number of her? Ma'am, there is any contact number of her?
Okay, I will give you. I will give you her contact number.
Okay, ma'am.
Okay. Thank you.
Welcome.